off is when you're reading examples in, well, first of all, you guys tend to just loathe, like literally hate, and just anything that you see words with math, you just kind of go, and you won't do it. And it's true. It's unfortunate, but that's what happens a lot. Now, what I'm trying to get at here with some of these problems is that it's a very simple, I'll get them from you later, don't worry about it, you just throw them and just leave it there. It's a very simple thing to visualize. I gave a little much. Will you pass the ones you have spared over there, please? Thank you. So take a look at the first problem. It's talking about a ladder leaning against the wall. Well, when a ladder is 20 feet and it leans against a wall, what does it look like? Well, yeah. Here's a wall. Here's a ladder. And what does the ladder rest on? The floor. Now, more often than not, your walls and the floor will be square. And if it says the ladder itself is 20 feet, which of those three side lengths becomes 20? The hypotenuse in this case. And then it asks, or it says that the ladder is 8 feet from the base of the building. Well, which of those is the base of the building? Is it going up the building or away from the building? So the horizontal distance is 8. And I think it asks you to find the angle of elevation. Well, is that this one, the top angle, or the bottom angle? Bottom. What trig function do you use? Okay, you use cosine. You have to use cosine in this case because you've got the adjacent and your hypotenuse. So as you get into these types of problems, they're not any more difficult than anything else we've been doing. It's just a matter that you have to draw the picture to figure out what trig function you wind up with. I still want you guys to write down what you're about to do before you do it. That way, in case you do press the wrong button somewhere along the way, we'll be able to figure out what you screwed up. Okay? Let's see here. Inverse cosine of 8 over 20. 66.42. Elevation. Not too terrible, right? But remember, this really goes with the idea that you can visualize what in the world they're talking about. How do you draw a diagram and go from there? Okay. Look at 6. 6 on this sheet talks about an airplane rises vertically for 1,000 feet over a horizontal distance of 5,280 feet. What's its angle of elevation of the airplane's path? Well, that means you have to understand what does it look like to be an airplane taking off. So we need an airplane.
You made that?
I did. Actually, I'll use we'll use this one. 6. So on number 6, it talks about an airplane taking off. Normally, airplanes take off from a runway, an airport, yes. So usually that means that they have to go like that, right? Do airplanes go straight up?
No.
Can an airplane go straight up? Yeah, it is. yes, airplanes can't take off vertically. You just have to do the right type of airplane. Now, in this case here, it says that over the course of a distance, it does that. Well, tiny. All right. What's up? What does it say? Well, yeah, because that's a rocket. Okay. So, is it an airport or a rocket port? All right, Mr. NASA. Let's explain it. Hold on. Is a square a rectangle? I almost fist bumped you. I'm like, oh, that would have been hurt. That's why I teach math. So it says that over time, it's 1,000 feet up. Over the course of a mile, it rose to 1,000 feet. What's its angle of elevation? The angle of elevation from the path that it took off would have been there.
Tangent.
Exactly. Are these always tangent?
No.
No. It always depends upon the information that you're given. If you're given certain stuff, that's why you have to draw the picture. That's why I wanted to make sure you guys understood what the difference meant because of a vertical height over a horizontal distance. No, never mind. I'll get to that later. So you said a second ago we use tangent, correct? All right. Tangent of something is 1,000 over 5,280. We have to hit the inverse button because we're looking for. What do you get? How much? 28. What do you get? 28. What'd I do? Same angle. I just saved the button. All right. So 1072 is the angle of elevation. Well, trig, in all honesty, trig, as we start this stuff out, I'm hoping that you keep saying that it's easy because I'm trying to make this extraordinary visual and just real straightforward so you don't try to mess with too much. Okay? Take a second, and I want you guys to figure out on number 8. I want you to draw it, set it up, and solve it on number 8. Okay? Stay off of your phone. You're worse at it today than she has been. Just terrible drawing skills. All right, fine, go draw it then. Ladies and gentlemen. Yeah.
I know, I did not mean to press it.
Good job.
Your car is bogus.
Wanna do this?
You're the best.
bug, apparently. Where's the flower on the dashboard?
What's the dashboard?
Go. I'll tell you 3 times. Just so you know, the dashboard is the thing that's in front of the steering wheel.
Oh, I know that, like the flat part right there.
Yeah, that's called the dashboard.
Yeah, well, like, I was confused. I thought you meant the front of the car. Because, like, usually it's like on the. No, like,
I got a couple more examples I want to make sure we get through.
Okay, guys. No need to do
I wanted to make sure we had a picture, we had examples that didn't have drawings so you can see how it works. All right, so ladies and gentlemen, heads up. As of right now, we got. No, you have to sit down. It's not done yet. As of right now, we have somebody. We have Herbie the love bug driving up to Rapunzel's tower, trying to pick her up and take her out. So Rapunzel, let down your hair, and then. All right, so there's Rapunzel. If I'm not mistaken, the angle of elevation from the car to Rapunzel is 32 degrees. So where does the 32 degrees go?
Oh, right here. I did that. I just didn't know if I was supposed to.
The tower is 150 feet tall.
Oh. I don't have any room.
Just 150. Well, 150. So the tower is 150 feet. Okay. And we need to figure out how far away is the car
Can I do it?
from the tower. Which means we have to use tangent. Yeah, how do you know it's tangent and you're not trying to find the hypotenuse? Look at why is it tangent?
Because you're going to find this way.
Explain to me why are you finding it this way?
Okay, so I find the distance, and this is the opposite, so that means that opposite is adjacent.
Correct, but why am I looking for my adjacent, that section, as opposed to the hypotenuse?
Because you want the distance.
I see. All right, I know where you're going with that. Remember, guys, when you're measuring distance, when you're trying to figure out how far something is, more often than not, you're talking about a perpendicular distance. It's where things make the right angle. That's why we don't use the hypotenuse for most of these problems, unless, like I was talking with you a second ago, about if you have like a kite string. You want to figure out how long the kite string is for how far the kite is up in the air, that kind of stuff. You were going to say? Well, what's theta in this case? So what is x? Show me what you're going to write. What was it the last thing you wrote down before you pressed buttons for your calculator?
I didn't actually finish the problem. Well, you called me up to draw the picture.
Sorry about meeting my expectations. Where's the unknown? Numerator and bottom, or the denominator?
Oh yeah, okay.
That was the quick. I had a brain fart.
Yeah, oh my god, sorry. And then, can anyone do the math for me, please? Well,
What was it? 240 point. Oh, I think it was 05. Go 2 decimals. I think it was like 0.48 or something
So
like that.
240.
Or 0.5. Thank you. Okay. Now, the other type of question you'll get from these also winds up being something like, if you flip over the sheet real quick, and you look at the one where they're talking about the climber on a cliff. If you flip over to the other side, on question number 11, they talk about a climber being stranded on the face of a cliff, and he was climbing up vertically. So if he's climbing up vertically, there are rescuers that they know that they are 1,000 feet away from the base of the mountain. The rescuers know that there are 2 angles of elevation. One of them is at 70 degrees to the top of the mountain. The other one is at 55 degrees to the climber. How far is the climber from the top of the mountain? What this is showing you, this is a very common setup where they use one picture to solve 2 problems. So if you have a 70 here, a 1,000, this gives you the mountain height. Okay. If you look at the other one, the 55, this gives you the climber height. Now, what trig function would you use to find the height of the mountain, knowing the angle and its adjacent? Tangent. Very good. So I would set that up, knowing that I'd have to go with a tangent of 70 is something over 1,000. And that was a really quick one to work with. When you had this stuff, when you knew the denominator, you just moved it over via multiplication, and you wrote down 1,000 times the tangent of 70 was your vertical height. The climber is at the same basic idea, where it's the tangent of 55 now, is the climber, we'll use C over 1,000. And when you put this stuff in our calculator, (27, 47, 48). What's that? I'm just writing it out because if you go back and you look at the diagram they give you, if you know the overall height and how far up the guy got, or person, how much do they have left? What would you have to do with those 2 different distances? That's all it is. This is a very, very common style problem for elevation or depression. You'll get the 2 distances, knowing that the overall was 27, 47.48, and this guy got up to 1428.15. That means this leftover distance, you just have to subtract out. Okay. When you subtract those out,
Go over there.
that was. He was in the Army, you should know that. I said SOS. When you subtract it out, what do you get, like 13 something? What do you get when you subtract those? 13, 19 point. So he made it more than halfway before he got stuck. All right. I don't think he was dead. They went to go rescue him. He didn't say he fell off the face of the mountain. I mean, if he fell, then we gotta go. Ah! Now, this is a very common problem. Now, another version of this one is when it works with depression. And I don't have this one right now, so I'm just going to kind of draw a picture here real quick. Earlier today, you guys probably saw the hot air balloon. There was the Remax hot air balloon floating around this morning. Okay. Now, let's just say, that's what I'm thinking. Let's just say for fun, the hot air balloon was 500 feet up in the air. Okay. And let's say you were in the hot air balloon and you were using it to survey distances. What's that? They could have been, right? Now, if you look outside the window here, do you guys all agree that if I'm looking at the stop sign from our vantage point, it would be an angle of depression because I'm looking down? Then if I look out at the trees out there or the cars going out further, that's also an angle of depression because I'm looking down from a building towards those objects. Now, what happens here, if I know how high up in the air I am, and I know I can find my two different angles of depression, I can figure out how far that stop sign is to, like, maybe that tree line. I can figure out that distance, same basic principle, by figuring out the far one, figure out the close one, and subtracting them. So let's say you happen to be, there was two cars. Oh, here's one truck, because I can draw a truck. Those are easy. There's another truck. So there are two trucks. There are two trucks so far away, but you were up in your hot air balloon because what you do. And you notice that your angle of depression to the far truck. Just squint and they look fine. Remember, angle of depression, I guarantee you're going to have a question on this when you see it. Your angle of depression is line of sight down. If my line of sight down in this case is 17 degrees, what's my line of sight looking back to
17.
it? 17. So this down here has a 17 degree. Okay. I do the same thing to the other truck. If I say that this one is, I don't know, 33 degrees, what is it going back up? 3. Now, I can use what trig function to figure out this distance from here to here? Tangent. I would use tangent to find this one out because I have an opposite. I'm trying to find the adjacent. So I have tangent of 33 is my opposite over my adjacent. When my unknown is in the denominator, what do? We switch them, a little exchange-o, change-o. Okay. So this distance, this horizontal distance, will equal 500 divided by the tangent of 33. Let's see here. 500 divided by the tangent of 33. 769.93. And then I do the exact same thing, but instead of being a 33 degree angle out here, I have a 17 degree angle now. So I have tangent remember, your depression angle is the same thing as the elevation angle, looking back. So I do 500 right? 16, 35, 40. And then to figure out how far apart those trucks are, what would you do? Subtract. It is a very, very simple scenario. It looks like it would be horribly complex, but remember, angle of depression, line of sight looking down, it's the same thing as looking back up at it. It is a very, very quick scenario style problem. Okay? I just wanted to make sure you guys saw a couple of these extra ones without pictures, especially dealing with angles of depression versus elevation. What's wrong? You're giving me squinty face. Okay, let me make sure you're on. Let me give you a couple of these to try. I've got 8 for tonight. Now, I do not have pictures. It should be relatively easy.
No, it's not on home. We're gonna go on straight.
Yo! What's that? It was 769.932. I did the 2 decimal places. I didn't go to the whole. I just went to. I always go to 2 decimal places. That's just how I know some of these say go to the whole number. That's why I want to keep it that. With the decimal. 1635.43. Track. Sorry guys, I don't know where it's my yeah, you do. So, is done. Just so you're aware, on these here, we've got a pretty good mix of elevation and depression. What was the one thing here? If you look at number 6 real quick, there were a couple of questions regarding number 6 and how it was set up. They're talking about a video camera installed in a bank. Now, a lot of times when you have these style word problems, they get to become a little overly worded than what you really need them to be. So as you start to learn how to go through these, you start to learn about what things are important versus what things you don't need. So if I'm reading this, it says the camera's being mounted on the bank wall to have a good view of the head tiller. People are asking, what's the head tiller? It's just the way it works. So if there's a camera mounted on the wall, we'll just put the camera there. The angle of depression that the lens, find the angle of depression, so we need to figure out an angle of depression to come back. If the camera is 5.93 meters off the ground, and the teller is 12.02 feet from the ground beneath the camera. Now, does that mean that they're 12 feet from this direction or 12 feet horizontally? Horizontally, because it's talking about beneath the camera. So beneath the camera, 12.02 feet, you're trying to figure out that angle because this angle is the same as that one. Okay. So even though in this case you're trying to find the angle of depression, it just means that you have to find the angle of elevation first, because the elevation angle is the exact same thing as the depression. You think it's 2? Oh, yes, yes.